is thrown off a 20-meter tall building at a speed of 10 meters per second, directed at an angle of 15 degrees below the horizontal. How long does it take for the ball to hit the ground, and how far from the base of the building does the ball land? So we know how tall the building is. We'll assume the ball is thrown at that height. So here's our ball. It's thrown at 10 meters per second at an angle of 15 degrees below the horizontal. So there's the rough sketch of ball. So it's going to go through projectile motion. Its path will be semi-parabolic. Again, we're going to ignore air resistance. So there's nothing causing the ball to speed up or slow down horizontally. And gravity is causing the ball to accelerate vertically. We will be able to use the kinematic equations. So these are all the variables that show up in the kinematic equations. Since the ball is not moving in a straight line, we must break it into its horizontal and vertical components separately. The only time you can use the kinematic equations once is if the ball, or your object, whatever the object happens to be, is moving in a straight line. This ball will not move in a straight line. So we have to break it into components. I'm going to make an executive decision. My origin's down here. Some of you like that. So what's initial x?
0.
What's initial y?
20.
Now there's nothing wrong really with putting it on top. You'd have initial y of 0 and a final y of -20. Doesn't really matter. Let's see. Final x is what we're looking for. Initial velocity. It's 10 meters per second, but it's at an angle of 15 degrees. So it's not 10 meters per second in x or y. We need to find out the components. The x component is adjacent to the 15, so it'll be 10 meters per second times the cosine of 15 degrees. That is 9.66 meters per second. So the x component, 9.66 meters per second. The y component, sine, because it's opposite. So 10 meters per second, sine of 15 degrees. .59 meters per second.
Negative.
Thank you. Negative. It's headed downwards. It's very important. So since it's headed downwards, we need an initial negative y velocity. Acceleration of the x is 0. They'd have to be wearing some sort of rocket pack or something along those lines. So that means the final velocity in the x direction is also 9.66. Acceleration in the y direction, negative 9.8 meters per second squared. So the acceleration of gravity. It's headed downwards, rate of 9.8. Alrighty. So how long does it take for the ball to hit the ground? Well, we don't have enough information in the x direction to find the time. So we will need to use the y information. We use this equation at 0. So we get 0 is equal to 20 meters, well, plus a negative. So negative 2.59 meters per second t. 1/2 of 9.8 is 4.9. So we have a quadratic equation. The positive result is 1.77. I also get negative 2 point something, but the negative answer doesn't make sense. We don't travel back in time. At least not in this class. So our time is 1.77 seconds. There we go. That's the answer to the first question. Yes?
I just about the calculator. What function was that quadratic under?
Mine's under solve, and then polynomial. I can help you look for it after class if you want.
Sure. Thanks.
If you don't want to do the quadratic formula, you can find the final velocity in the y direction first, and then find the time. But again, you're going to have to be careful because you're going to use that v squared equation. So you'll have to choose plus or minus is appropriate. But you can approach it the same way as we did the last one. So now, how far from the base of the building does the ball land? We're looking for x. Initial x is 0, acceleration in the x is 0. So x will be the initial velocity in the x direction times the time, which we just found. Meters. That's how far it